In this video, we are going to check how to find the net electrostatic force on a given charge. So here we have got a problem which says the charge is Q1 2 times 10 to the power negative 7 coulomb and charge Q2 negative 4 times 10 to the power of negative 7 coulomb and Q3 negative 1 times 10 to the power negative 7 coulomb are placed at the corners of the triangle as shown below. What is the force on Q1? So we want to focus on Q1 charge. That's what they are asking us to do. So we want to get the forces acting on Q1. So Q1 is going to experience two forces, one because of Q3 and one because of Q2. So because of Q3, which is a negative charge, Q1 is a positive charge, so it will attract Q1, so the force will be downwards, that is F31, and Q2 is also going to attract it because Q2 is negative and Q1 is positive. Let's name that as F21. So now we have got two forces, F31 and F21, acting on Q1. Using Coulomb's law, we can find F31, which will be KQ3 Q1 over R square, and R, we can check on the diagram. R is 3 meter, we can substitute that, and all the other values we can get it from the problem. That value will come out as 1.99 times 10 to the power negative 5 Newton. Now F21, again we can apply the formula for Coulomb's law or electrostatic force, KQ2 Q1 over R square. Substitute the numbers as given in the problem for the charges. K is a constant and R is 5 meter. Again we can calculate and get a number for it. Now we have got two forces which we have to combine and get into combine and get the net force. So we can see that F31 and F21 make an angle which is not 90. That means we cannot use the Pythagoras theorem to combine it. So we need to first find the angle, which is theta in this diagram. I have labeled it as theta, and we can use tangent theta or tan theta equal opposite over adjacent, and using the information given in the diagram, it is 4 over 3, and we can get the value for theta, which will come out as 53 degrees. So now we have got the two forces and the angle theta between them, which we have to combine it into one single force. So let's get the values here for theta, F21 and F31. Now we have to check where is the y-axis and where is the x-axis. So we can see the y-axis and the x-axis drawn, and we can now analyze that F31 is on the y-axis, but F21 is not on the y-axis or the x-axis. That means we have to do the component method. So we will form a table which makes our job easier to get the x and y components of the two forces. So let's list the forces F21 and F31. F21, let's do F31 first, because F31 is on y-axis. It has no x component. It's all of the F31 is on the y-axis. So only it will have a y component and it will be negative because it's pointing downwards, and the x component will be 0. F21 will have both x and y axis because it's making an angle, and that angle we already found, which is 53 degree, and that's with the y axis. That means the y component will have the cosine component, and also it will be negative because it is going to point down. We can also see F21 is pointing down and right, so its y component will be negative and the x component will be positive because it's pointing right and down. So right means positive, down means negative. Now we can use our calculator to get the numbers. Now the next step is to get F net, the components for F net. So we'll combine the x component and the y component. Once we have got the x and y component for F net, we have to use again, now we can use the Pythagoras theorem because we have got the x and y component. So radical fx square plus fy square we can substitute the numbers which we have got and put it in the calculator to get the magnitude of F net, which is 4.37 times 10 to the power negative 5 Newton.